All right, so this is, I'm going to work through the worksheet 1.1. If you have not done it yet, it's a good idea to print it off and maybe do a couple or do it with me. So in other words, you would do a couple problems and then check the video and then go back and do a couple more, etc. And the worksheet can be found on my Canvas page. Okay, so this the main two concepts this thing is dealing with is distributive property, commutative property of addition and multiplication, and just understanding the different powers. And you'll notice that I will hardly ever, if ever, mention any exponent rules, because I think the exponents rules are great if you have them perfectly memorized and know when to use them, but most people mess that up. So I really emphasize just understanding what an exponential is and then using that knowledge to simplify these problems. So in this first problem, number one, basically, and you wouldn't have to write all this out, but basically what you're thinking here is this is nothing but multiplication. In other words, it's 2 times x times 4 times x times x times x times y times y. If you look at it like that, it becomes very clear that you have nothing but multiplication here. So you can multiply in any order you want. So you could do 2 times 4 is 8. There's 1, 2, 3, 4, 5 factors of x. So that would be x to the 5th. And there's just 2 factors of y. So that would be y squared. Okay, and the same idea over here in number 3. But instead of writing it out like that, I wouldn't necessarily recommend that, but that's what you're thinking. So it's all multiplication. I can do it any order I want. So 7 times 12, of course, would be 84. And then I notice I have 5 q's multiplied here, 3 q's multiplied there. That would be a total of 8 q's multiplied together. And then finally just r to the 5th. Okay, I skipped this one because these two are kind of similar. I'll come back to this one. This one is just you need to multiply again, it's nothing but multiplication. So you got 3 times 2 times 2 times 2, which is, 2 times 2 times 2 is 8. 3 times 8 is 24. Okay, here's another one where there's nothing but multiplication going on. People get a little bit confused when they have a power raised to a power. So let's, again, if you just follow if you understand the way exponents work, this bit right here is really just 14 a to the 4th b to the 6th times 14 a to the 4th b to the 6th, because that's what squared means. And this is the same idea, only there's 3 of them. So if you think that in your mind, you know that this is just 14 times 14, which is 196. And that's a to the 4th times a to the 4th, which is a to the 8th. b to the 6th times b to the 6th, which is b to the 12th. And then over here, I'm going to have, a to the 6th times a to the 6th times a to the 6th, that's a to the 18th. And c cubed times c cubed times c cubed, that's c to the 9th. So then we still can multiply the a's together. So that's 196 times a to the 26th power, b to the 12th power, and c to the 9th power. Okay, now number 5 is a little bit different because we're not just, it's no longer nothing but multiplication. So I have to be careful here, and we got some parentheses also. So order of operation tells us we got to do the stuff inside the parentheses first, but I can't because I can't add 12x and negative 5. That's not possible because they're not like terms. So I'm either stuck unless I can get rid of the parentheses. Well, the distributive property says if I have something outside a parenthesis with terms inside, I can distribute that through if it's multiplication. Well, so here, really, the 12x minus 5, those parentheses aren't doing anything because there's nothing being multiplied outside. But here, there is a negative outside the parentheses, so I can drop the parentheses if I just distribute that negative, meaning that I multiply negative 1 times 7 and negative 1 times negative 11. So that would be negative 7x and positive 11. And then, of course, there's a plus 3x here. Now, once again, we really have nothing but nothing but addition here. If we think of these terms as, this is one term. And I know you might say, well, there's a subtraction there. Yes, but subtraction is just the same thing as adding addition or adding the opposite. So we could easily change that to plus a negative 5 and plus a negative 7x. Now we have nothing but addition. And so we're going to go through and find like terms. So, and we can do it in any order we want because the commutative property addition. So 12x and negative 7x, that's 5x. 5x plus 3x, that would be 8x. And negative 5 plus 11, that would be 6. Okay, same thing here. Okay, so number 6 is also going to employ the distributive property because we have a 4 times a parenthesis with 2 terms inside and a 6 times a parenthesis with 2 terms inside. So if we distribute the 4 times 7, that'd be 28x squared, and 4 times negative 8, that'd be a negative 32. 6 times 5 would be 30x, and 6 times 10 would be 60. And we do have some like terms in the negative 32 and 60, but the rest are not like terms, so we'll just rewrite them. 28x squared plus 30x plus 28. Because 60 negative 32 is 28. Okay, here's another one with some powers raised to power. So this is really just 3 squared, which would be 9, y to the 6th squared, which would be y to the 12th. And these are just, there's nothing outside the parentheses, so I don't have to worry about that. I think I'm going to make that a little thinner. There we go. This will be easier to see now. So we said 3 squared is 9, y to the 6th squared, that'd be y to the 12th, times x to the 5th, y squared, and z. And then I look, is there anything else I can multiply together? Yes, the y to the 12th and y squared. So that's a total of 14 factors of y. So that'd be 9y to the 14th, x to the 5th, and z. This one is just addition, and then addition and multiplication mixed. I cannot multiply any of the stuff that's being because it's different, they're variables and numbers and stuff, and I can't add anything because they're not like terms. So that's my answer right there. There's nothing I can do to simplify it. Oops. Here's another one where we need to distribute the negative sign. So I'm going to rewrite this as 2x squared minus 3x plus 7, and that would be positive 3x squared minus 4x plus 7. And then I look for like terms. So the 2x squared and the 3x squared are the same terms. That would be 5x squared. And the negative 3x and the negative 4x are the same terms. So that would be negative 7x. I mean, not same terms, like terms. And 7 plus 7, that'd be 14. Okay, here's one where we got some addition or multiplication and division mixed, but multiplication or division is just multiplying by the reciprocal. So if we're careful, we can actually do these in any order we want. Like, for example, well, there isn't any mixed ones there. So what I would probably do is just apply the cubed. So negative 4 to the 3rd power, that's negative 64. And s to the 6th to the 3rd power, that would be s to the 6th times itself 3 times, which would be s to the 18th. And on the bottom, we got t cubed to the 3rd power, that would be t cubed times t cubed times t cubed, which would be t to the 9th. And r to the 5th to the 3rd power, that would be r to the 15th. Number 11, this is the first time we run across a negative exponent. So remember, negative exponents basically mean you're raising it to the 3rd power, but then taking the reciprocal, which means you flip the fraction over. So one way to handle this is just begin by flipping it over. Go y to the 12th over negative 2x to the 4th, y to the 9th, and then just change that to 3. Now you don't have to worry about the negative exponent anymore. And then I could just do it like normal, although now I notice there's a y to the 12th and a y in the top and a y to the 9th in the bottom. So it makes sense to simplify the stuff inside the parenthesis first and then apply the cubed. So notice y to the 12th, that means there's 12 factors of y on top, 9 factors of y on the bottom. So 9 of these y's will cancel out with 9 of those, leaving just y to the 3rd on top. And then a negative 2x to the 4th on the bottom. We're still raising that to the 3rd power. Now I'm going to go ahead and apply the 3rd power. So that would be y to the 9th on top. And negative 2 to the 3rd power, that'd be negative 8. and x to the fourth to the third power, that'd be x to the 12th, because that's x to the fourth times x to the fourth times x to the fourth. Okay, here's another one where we can raise it, the whole thing, to the third power. I could simplify first, like the 2 and the 4, so it would leave me with d to the fourth over e, or 2e, I mean, raised to the third power. So then if I apply the third power, that'd be d to the 12th over 8e to the third. Okay, we're cruising here now. Now here's one where the negative exponent is just mixed in with the other stuff. So again, a good move to make, hey, there's something missing there. I think there's supposed to be something there. I think that's supposed to be a W. Okay, so again, what I would do first is take care of the negative exponent. So I'm going to rewrite this as 16w to the 7th over negative 4w v, and then that v to the negative 2 becomes a v squared on the bottom, because that's another way to take the reciprocal, is just switch where it's at in the fraction. Now we can simplify. 16 divided by negative 4, that would be negative 4. W to the 7th divided by w to the 1st, that'd be w to the 6th. And then on the bottom we have v times v squared, which would be the v third, v to the third power. And this one's pretty straightforward. Just got to look for anything on top and bottom that'll cancel. So notice a is a factor of the top a couple times, or 5 times, and a is a factor of the bottom twice. So we can cancel a couple of those out. That would give me a cubed on top. And there's 5 factors of b on top, 3 factors of b on the bottom. So a bunch of those will cancel out, leaving b squared. And then finally 5 factors of c on top, 4 factors of c on the bottom. So that means just c on the top. And of course that negative is still there, so we bring in the negative. So notice the whole bottom got canceled out, so we don't even need a bottom anymore. Here's another distributive law application. So got to distribute that 4. So that would be 24x cubed minus 16x squared plus 28x plus 4. So that's that first parenthesis. Second parenthesis, I'm just going to distribute the negative, so that would be a minus 4x cubed plus 2x squared plus 6x and minus 1. Then we just got to look for like terms. 24x cubed minus 4x cubed, that'd be 20x cubed. And negative 16x squared and 2x squared, that'd be negative 14x squared. And 28x and 6x, that would be 34x. And 4 and negative 1 would be positive 3. There's a couple of these that are missing stuff, aren't they? That should be x, and that should be a t, maybe. Okay, a lot of these are similar to what we've already done, so I'm going to go ahead and do the next 6 off camera, and then I'll come back on and show you them. Okay, so I did 16 through 21. There's 16, 17, and 18. And there's 19, 20, and 21. This one is mistake. I'm putting this on. I meant to move these radicals to a new worksheet, but I'll do them anyway. But this is not really, we haven't covered this stuff yet. Actually, I think I'll save 22 and 23. And well, I guess I'll just do them and we'll talk about them later. So the answer to this would be 3xy squared times the square root of 3yz. That would be the simplified form of that. And this one is going to be 2 times the square root of, see, that'd be 12, that'd be 3x. And this is going to have a 5 square root of 3x, so that would be 7 times the square root of 3x. But again, we're going to talk about those in the third week, or the third homework. So we'll do a lot more of these in the future, but in case you do know what you're doing with these, You can check yourself. All right, so here's another division, distributive property. So remember, it's just like the distributive property. If this, you could think of this as 4x to the fourth minus 6x cubed plus 18x squared divided by 2x squared. That'd be another way to write that. And so we can distribute this divided by 2x squared through. So 4x to the fourth divided by 2x squared, that would be 2x squared. And negative 6x cubed divided by 2x squared would be negative 3x. And 18x squared divided by 2x squared would be 9. Here's another distributing the negative, or distributing division. And notice it doesn't go evenly though, so this would end up being just 3 x over 2, because the x's will cancel and nothing else will. This would be plus 5 halves, because just the x is canceled. And this would be 9 over 2x. Here's another application of the distributive property. Here I have a parenthesis times a parenthesis with multiple terms inside. That means I got to multiply everything in this parenthesis, every term in this parenthesis, by every term in that parenthesis. So that means I need to multiply 4x times 2x and 4x times 8, 6 times 2x, 6 times 8. So that would give me 8x squared plus 32x minus 12x minus 48. If we combine like terms, we get 8x squared plus 20x minus 48. Same thing here. 3x minus 9 to the second power means 3x minus 9 times 3x minus 9. So if we multiply every term in this parenthesis by every term in that parenthesis, we get 9x squared minus 27x minus 27x plus 81. Combine like terms and we get 9x squared minus 54x plus 81. Last round here. So this says evaluate. So far we've been simplifying each expression, so we just write it in simplest form. Now we're supposed to evaluate expression, which means we're going to plug in numbers, values for the variables, and simplify towards just one number. So in here, I'm going to put a 2 in for x, so that would actually be, this would be 3 times 9, which would be 27. And I put a negative 2 in for y, so that ended up being a negative 4. And this is 5, and negative 3 times negative 2 would be a positive 6. So that's going to be 23 divided by 11. Right? Here, those are little symbols. If you don't recognize them, are absolute value. So x squared is 4, negative 2 squared is, or cubed is 8. No, negative 8. So that'd be 4 minus 8, which would be negative 4. But of course, the absolute value of negative 4 is 4. And one more. If we replace y cubed with, now actually, before I plug anything in, I think I might simplify a little bit. So this is going to be y cubed on top. And I'd have 9x cubed on the bottom, and all that stuff's going to move down. So that'd be times 3, or actually, 3 squared is 9. And z squared and x squared. So now we can simplify that. That's y cubed on top. And that'd be 81. And x cubed times z, or x cubed times x squared, that'd be x to the 5th. And then z squared. So that's just simplifying it. Now I'm going to plug in the numbers. Y is negative 2, so that'd be a negative 8 on top. 81 times x to the 5th. Well, x is 2, so x to the 5th would be 32. And z is 1, that's just 1. So it ends up being negative 8 times, so 81 times 32 would be 2,592. All right, so that's the conclusion of this video. Let me know if you have any questions.